Today, let us start modern water tube boilers. The appearance of water-cooled furnace walls, called water walls, eventually actually led to the integration of furnace, economizer, boiler, superheater, reheater, and preheater into the modern steam generator. Actually, by the name modern steam generator, you are meaning a integration of varieties of different type of equipments or machineries, like say furnace, which where we are burning the coal, economizer where you are using this using and what you'll say, where you are preserving some of this additional heat to be used into heat up mostly incoming air to improve the boiling itself. Boiler where we are using this heat from furnace and economizer to convert the liquid water into steam. Superheater, here after formation of the steam is superheated, which is at around temperature 100 degrees centigrade or 110 degrees centigrade, just around boiling or slightly more than that of water boiling. But where you are heating this superheater so that it is goes up to around 560 or 580 degrees centigrade, so that no moisture content remains present inside the boiled air, but everything is converted. I mean, no water content remains present in the water, but everything is being converted to steam itself. Next, reheater. Sometimes it is also reheated in a heat. This superheater is used in a different stage. While I'll come to superheater, I will explain in a different stage where we are reheating according to your requirement to the moist air itself, moist swing and air itself. Now, next is air preheater. What is air preheater? Air in normal room temperature, normal atmospheric temperature, we generally don't use. We use the additional heat of this furnace to reheat the air, nearing to the heat the air to the nearest to the boiling point. I mean the burning point of the fuel used in the furnace itself, so that by use of the hot heat heater pipe, these fuels can be readily and quickly burned. Now, next, what is this? But everything is you are generating heat and generating heat, but you cannot stay or you cannot keep your furnace intact when if it is overheated like this. So you are supposed to be cooled to a certain extent, and all the furnaces of the walls are supposed to be cooled by water, and where it is made like this, it is being covered by cooling water pipes surrounding the furnace. Especially it is they are used in superheater and economizer compartment competition or compartment wall itself, and in various other components. So we are having water tubes through which the cold water from maybe nearby pond or maybe nearby river is falls to keep the temperature of the surface or the surrounding of the surface or near surrounding of these particular equipments to a closer to the bearable limit, closer to a bearable limit. And now uh, the various other components such as say screens, dividing walls, etc. Uh, what is screen exactly? The walls we don't have any clear cut totally open. It has different screen or partition, so that through which this molten flue gases passes through. It doesn't go directly to the wall of the boiler steam generator, but through different equipment so that the circulation goes well and more and more amount of heat is being used totally to the for our purpose of boiling of the water itself. Now, this design concept of water boilers are say given in figure next page. I am showing you next page the design concept of the water tube boilers. And type A, just showing you next page. Screen share. Uh, Just 1 second. Here are the different sketches of water tube boilers. You see the type of a boiler circulation of water is around natural circulation, forced circulation, once through, and once through is recirculation, forced. It is like this. Now here, what we are doing, it is the type A type of boiler. This is natural circulation. Uh, uh, Type A of a boiler with natural circulation, as in type here is shown here. And now the heat transfer to the walls around the walls is mostly radiation from the furnace fuel flame to less dry convection from flue gases itself. Now, how the transfer, what is showing here is one for boiler drum. This is here. This round shape is the boiler drum itself. Two is for steam separator. Uh, Two is steam separator. Three boiler feed pump itself. Where just 1 second. Uh, what we are saying, I'm just repeating again. This is the boiler drum itself. Steam separator is not visible here, but this is the steam separator itself. Boiler feed pump is the three here. Here the pump required for feeding the water from throughout the circulation of the boiler itself. And five is the economizer here, and six is the evaporator, and mostly that is the boiler equipment itself. This is here, and this is here, and this is here. What is going on here? The heat transfer. The type A is a natural conventional water boiler, where heat transfer to water tubes around the walls is mostly radiation from the fuel film and rest to the convection from flue gases. Now, first of all, how the heat is being transferred to the water? It is mostly radiation, but to a certain extent, convection means just the connection between the adjoining hot flue gases and the boiler area itself. Mostly it is given by transport is given by the radiation itself. The natural circulates are used up to the steam pressure approximately 180 bars. Around 200 or 180 steam bar, this natural circulation strength can be used with the operation of the steam from the water taking place in the boiler drum. Now, where in the boiler drum, we know we have discussed what is the function of the boiler drum. Mostly, boiler drum is doing uh, using is a method or a in between equipments which is being used for the natural convection, natural circulation of steam, steam, and water steam mixture inside the boiler inside the power circuits, where boiler drum contains half of its filled with water which saturated with steam, and rest of the half is will be fully saturated around 100 to 6 degrees steam, which is sent to the superheater itself. And the liquid water saturated with steam being circulated, and then and goes through the wall is through the furnace inside this tube, through the tube where tube is exposed to the furnace flue gases, and it is converted the water into steam and again sent back to the whole uh, to the drum itself. Whole process is carried out by natural convention with the use of any pump or like this, because you know the heavy water will by its own weight will comes down and to the down common and goes to the top goes to the pipe itself inside the reheated pipe itself. There it is converted. So by mixture of steam and water mixture goes to the drum itself, where heavier water goes down, accumulated here, and lighter spring goes out. This is the process of the use of the natural heat drum itself. Use of the drum itself. The natural circulation generally spins pressure up to 180 degree bars is allowed, with separation of the steam from water taking place in the boiler drum. At this pressure up around 180, the water is being separated in the drum in the boiler drum itself. Boilers with forced circulation, boiler with forced circulation. Just 1 second again. Uh, Boilers with natural circulation. Hmm. Boilers with certain forced circulation by special pump. Sometimes, when we are using, you have to use the boiler in higher pressure only for natural movement of the water under the gravitational weight of the steam and water is not sufficient. So where we have to use the circulation by a special term, boil called Lamount boilers, as shown in by B and C. Here, other pumps are used here, like here and here, where uh, four circulation. This is the circulation pump itself. Steam they are separated. Two, this is the steam separator. Is the 1 through 12 boiler. There is a steam separator is there. Okay. Now, the they said for a certain amount, boilers are forced circulation steam pump called Lamount boilers, as shown in B, and type B and B in the figure next page. In this page, this offer a certain amount of freedom in the arrangement of evaporator tubes and the boiler drums. Certain amount of freedom in the arrangement of boiler tubes and water drums, so that as you are in the riser in the natural convention, you don't have a much liberties. You have to keep this one portion of your pipes, this piping system inside the down cover. Another portion is inside the riser. rider is exposed to the flue gases itself. And as we have no influence over the movement, we have to depend only on the weight of the boiler and boil weight of the water tube boiler itself, weight of the water and water vapor water mixture itself. Now here, as we are using a pump here, say 4, so we have some certain amount of freedom is available in the evaporator tubes and the boiler trunks. As such boilers can adapt to limitation in height and space, so they are available in steam pressure up to 200 bar. So here the space is less required because you are pumping it. You don't have to depend on the high volume of or amount of water, so that which also increases the space for its occupation. And so your space is rather limited and smaller than the natural circulation system. And you can it is good, you can rise the steam temperature over 200 bar itself. Now the boiler itself can be uh, designed to operate at pressure above the critical pressure. We know the steam air pressure critical pressure is 221.22 bar. What is the critical pressure? I'm telling you again. There is a particular position in the TS diagram. There is a particular position in the TS diagram of the steam and water vapor where there is no such places of in such, actually if the pressure is less than 200 or even less than 100 bar or so, they are proportional first the liquid water, and from the liquid water is it is converted into steam, then goes to the steam itself. But at the critical pressure, liquid water, there is no water and vapor portion of the among the system itself. So liquid water is directly converted to the steam totally and directly converted to the steam itself at the critical pressure. So there is the question of moisture with filled with water particle will not arise here. Now here no drum is necessary because you are not accumulating or accumulating or storing the water vapor air mixture and total vapor air. Here total water is converting into the steam, so nothing is required to be accumulate or for circulation. Now because both steam and water are the same density itself, so there is no circulation is required. This total amount is converted and sent to the superheater itself. The water enters the bottom of the tubes, completely transformed with the steam by the time it reaches the top and passes through the tubes only once. For this, it is known as once through boiler. Here, we are using this system where we are using this superheater critical pressure system here. This is called once through boiler, where it comes the water comes through here. Here is the pump itself, boiler feed pump, where it's a particular valve. It goes here totally to the economizer, and from the economizer it already heated in the economizer from the tube, from the fuse itself. Then water goes back to the boiler where it is immediately converted into steam itself and goes out from the top itself, where we are using a steam separator, so that if for any sort of a chance of any other boiler particles, I mean the water particles or any other system, it is separated and by means of a buffalo wall inside, and only steam goes through the superheater itself. So it is once defined as once through boiler. There is no stream down like here and here. So it is totally goes to the diagram itself. Now let us go through the schematic diagram. Now there it shows a schematic flow diagram of a common natural circulation of steam generator. Water at 160 degrees centigrade here. It is the circulating pump. This is the schematic drum circulating pump. Everything is given. What is shown here? This is the economizer. It is the superheater, furnace valve through which the tubes are going out in a circulating manner, and that goes to the economizer itself, then comes back to the circulating pump itself, and that's like this. That is for the natural tube boilers. And at the point B, here we are having the distributing header, then circulating pump itself, then from the here it goes to the furnace wall goes to from furnace to the goes to the economizer. A portion comes back to the to circulating pump for against recirculation, and remaining portion goes out from the steam itself. Now the natural, it's a compound natural circulation given steam, steam generator. It's initially it is given like this. Now water at supposed to be kept at 170 to 206 degrees centigrade, depends on the boiler pressure. Higher the pressure, it requires higher amount of temperature to for its boiling. Upon the high pressure feed water heater into the economizer and leaves saturated or as a two-phase mixture of low quality. So what is going on? First, the pressure feed water is coming in inside at high pressure. It goes to the feed water heater itself, where in which comes to the economizer. You see here, it comes to the economizer and then leaves saturated or as a two-phase mixture of low quality. Thus enters the drum or midpoint lecture. The drum itself here uh, enters the drum, and water the heads are connected to the tube itself. The water in the riser tubes, uh, which is situated outside the furnace. Then the drum or at midpoint lengthwise, which is situated outside the furnace. So drums is not being heated by the mixture itself. These headers are connected to the headers connected to the water pumps, water tubes that lies in the furnace of the wall and acts as a riser. So we have headers here. Headers, it only I explained you earlier, is nothing but a space or chamber where all the pipes are connected, all the pipes carrying water or steam or water mixture is connected, so that everything is accumulated there and then goes to the next stage. Next, as a riser itself. Down, water headers are all connected to the water tube itself, and the line, the furnace wall, and acts as the riser itself. The water in the riser tubes receives heat mainly by radiation from the combustion gas and coils. So, as we know that riser tubes goes through the inside the furnace itself, and for all the fume or heat generated in the furnace are transferred into the riser, where boil water is being changed to the vapor itself. The riser differential between water the riser, the density differential between the water and the downcomer and that in the riser helps the circulation like this. So as the water in the downcomer, total water or water steam vapor has a higher density and thus higher weight, it goes down. It goes down to make the circulation possible itself and create a density differential. This density differential of water and downcomer, that of the riser, helps the surfacing. So downcomer, the water and water vapor mixture inside the downcomer is of higher density, and those which is being boiled and converted to steam in the riser, and so downcomer is as the amount of water and water vapor mixture of higher weight flows through the circuit and pushes the circuit into the vapor itself, and thus it ensures the circulation. Steam is now separated from the bubbling water. Now it goes to the drum, and it is same for the bubbling separated in the bubbling water in the drum and goes to the convectional part primary superheater, where heat is being absorbed by convective method. From the convective supervisor, steam goes to the radiant superheater, and RSH, convective supervisor, is short written as CSH, convective superheater. Then initially it is absorbed by convection, and then it goes to the reactive radiative supervisor or RSH installed at top of the furnace cell, where heat is being absorbed by radiation, and steam having the radiant superheater. Steam leaving the radiant superheater goes to the desuperheated, where water is of high purity spread into the spring to bring down. Just I'm going to the page. Uh, Uh, Steam is now separated to the boiling water in the drum itself and now goes to the convective or primary superheaters. So, for the natural convecting boiler system, there is a drum where which contains water at the bottom and water vapor and steam mixture and total stream at the top side of the drum, where it is sends it to the real I mean superheater itself. There are two portion of the superheater. There are two portion of the superheater, and steam goes to the radiant superheater. First, there is a convective or primary superheater where heat is being absorbed by convective method, and radiant superheater where heat is absorbed to the absorbed and it's installed at the top of the furnace where heat is being absorbed by radiation. Convection means it has general by convection heat. There are conduction, convection, and heat radiation. It is not no that cannot be in conduction, but it is flue gas is not directly come in contact with the boiler or steam itself. It is by the presence of its surroundings. It heated the boiler inside the tube when got it converted into superheated steam itself. Steam after superheated, it goes up in a position in the top of the furnace where the total radiation, the radiation of heat coming out will heat make it further heated. So there are two portions, one is convection, one is super radiation. One portion of the superficial is convection CSH type, and another portion is radiated type, which is installed at the top of the furnace, where heat directly absorbed by radiation itself. Now, the steam leaving that direct radiant superheater goes to the T superheater, where water of high purity is sprayed into the steam to bring down the steam temperature to the desired level. So, after total material is converted in the stream into steam, we are sending a spray desuperheated cell where we should control the steam of the heat of temperature or as well as the heat content of the steam up to our desired limit, not more than that. So we spread the steam here there by means of a cold and pure water itself, pure and pure water itself. This type of water should be of high purity. Otherwise, normal natural water we have a lot of impurities inside it, which will get absorbed by the steam itself, and it will totally it can create corrosion over the turbine blade itself. Now, uh, steam temperature of the well it exists, which if it exists later. Generally, you have to control the steam up to a different requirement by spraying the water inside here, because by means of conduct and convection in the superheater, the steam may be heated much more than is requirement, around 500 560 degrees centigrade. It may go up to 700 centigrade, which is not required, may be detrimental to the other portion of the boiler itself, like or turbine itself. Next, from the desuperheater, the stream finally goes to the pedant superheater PSH for further superheating before it leads to the main stop valve to the high pressure turbine itself. So we are having primary superheater, radiant superheater, and pedant superheater means PSH. Primary superheater is being superheating the steam from 100 degree, 160 degrees to around 200 degrees centigrade by means of convection, means by the presence of the heat comes from the fluid gas around the tubes carrying the water itself, then then goes to the radiant superheater. It is further heated by means of the radiation, which higher amount of heat is being transferred by the by the hot atmospheric air surrounding the tubes itself. But thus the tubes can be overheated. I mean, the steam inside the tubes can be overheated and much more than our requirement. Say around our requirement can be around 560 to 550 degrees centigrade. It can be heated up to 700 degrees centigrade. So we have to control the heat to a water spraying system or de-superheater. It is called de-superheater. First superheater, the de-superheater means it is reducing the temperature of the suite temperature of the steam itself up to a required level by spraying 100% pure water inside the string itself, which will reduce to the at room temperature, which will reduce to the temperature to a considerable extent. Again, it's sent to another superheater, the pendant superheater, pendant, where it is just superheating to a certain extent and by means of flue gases, by means of radiation, and up to the desired levels of temperature itself. Next, it goes to the main stall valve, and from the valve to the high pressure turbine itself, where here valve is used to spray to control the flow or rate of to improve the kinetic energy of the steam vapor, so that it can strike to the turbine blades to a considerable amount of energy and pressure itself. Thus, high critical pressure and high temperature of the superheater this and these two energy function is being converted to high velocity of spring, which is impinged on the belt of the turbine, thus creating the rotation of the turbine to a considerable height, say around 6,000 rpm or so. Now, now both radiant superheater and pendant superheater are often termed as secondary superheater. So initially the uh, primary superheater is CSH, and both radiant and pendant superheaters defined as the uh, sorry, both radiant and pendant supervisors are called as secondary supervisor itself, superheater itself. Steam existing there, steam existing there, exiting the high pressure turbine. Steam existing the high pressure turbine goes back to the furnace for being re-superheated again to the desired temperature in the reheater steam. In the reheater steam after being reheated flows to the after being reheated flows to the intermediate pressure IP turbine and for further extension itself. So what is going on? After there are two set of supervisors, superheaters actually in three in content, one primary and two secondary superheaters, and in secondary superheaters it is being heated, and in between the uh, first secondary supervisor second super first radiant supervisor and pendant supervisor, we are having de-superheating by installing the pure water to control the temperature of the steam up to a desired limit itself. Next, this they passes through the liquid valve which controls the flow by converting the to under the heat and pressure energy to the kinetic energy, thus spraying high speed steam to the high pressure steam to the boil turbine blade itself. So the after from the exiting, next comes the steam coming out from that high pressure turbine. Then it is not wasted but goes back to the furnace for being again re-superheated to the desired temperature in the reheater. So here, as it is losing a comfortable amount of heat by means of this converting to the speed, then again it is reheated to a certain extent, then sent to the intermediate pressure IP turbine for further extension. So we have five primary, intermediate, and secondary turbines. So there from steam after exhausting from the primary turbine itself goes to the reheater, and they heat it to a certain extent, and then that heated steam again impinges to the secondary, or I mean the intermediate turbine, so that it starts rotating, and this turbine may be act on the same shaft, but it can supply to different section, or they can supply to the same section, or they can supply to the different supply to different section himself. That heat being radiated due to the intermediate pressure turbine itself. Atmospheric air feed by the forced draft PD. Forced draft is normally called FT fan. Forced draft fan is nothing but a fan, so that it can create the pressure of circulation by sending air, atmospheric air in with a high pressure, then preheated by the outgoing flue gases in heat exchanger called air preheater. It is a heat exchanger, nothing but just converting the outgoing flue gases to a certain extent, and incoming air fed by some pump or like this is forced, has created forced draft, and thus it is again heated in the preheater APH air preheater, then air heated to the run. So far, before this section, we are using heating the steam. Now we are heating the incoming air. That is, so it is, we first using air preheater APH. They are heated to the desired temperature, which varies from 250 degrees centigrade to 400 centigrade, depends on the coal burning. So the amount of heat the air is heated is around 250 to 400 centigrade. So mainly it depends on the heat, amount type of the coal it is burned in. Coals with very high octane requires less amount of heat because it can be easily converted to the easily burns and generates the heat energy itself. The coal after burning is split into two streams: primary and secondary stream. Hot primary air hot primary air is generally 15 to 30% remains. So there is a circulation here. We are absorbing certain amount of air from the firing and as well as using the circulating air inside. Generally, the hot primary air is 15%. It is the air conditioning system itself. Just 1 second. Combustion mechanism. Now, what we are having here, what is shown here, this is the water. The water system is coming here, the site of disposal. It is going out to the maybe to the pond or to the tube itself, and the tube means here the coal. This is the coal structure here, and primary air to coal, air plus coal coming out from here. It goes inside this furnace wall itself. Well, this is the portion of the wall with certain primary itself. Here, secondary air and primary air and clinker grinder is shown here, and from here it goes up the radiant superheater. This is the radiant superheater itself, and here the temperature of the furnace is around 1300 degrees centigrade itself. The primary air and coil are being sent through this primary box itself. Now there is a downcomer. There is a downcomer which there is a wind box which gets the heat from which the wind required with the wall, wind required for preheated wind sent to the wall of the furnace itself. Then here is the desired drum we have, which is controlling the natural circulation of the boiler, and everything. Thus, all the drum is here, and drum internals are here. This is the drum internals, and this superheater goes from these two small 8 points at the dual superheater itself. From here, the 150 degrees centigrade, then to turbine, beds running here, and reheater. This is the reheater content itself. This is 400 degrees centigrade reheater, and this is the economizer portion of the economizer portion. Here, APH is the acid pressure hours. FD fan is the draft which is creating the draft of air. The electronic supervisor, electronic precipitator, and ID fan itself. Thus, here the heat is just coming out. Heat of the air is coming out and goes to the electronic precipitator, then ID fan, then goes to the draft of going out of the air itself. So the flow starts taking thing. This is the water flow which is coming out, and this is the inlet of the air which is going air which is burning the fuel, and thus creating the heat, high heat energy, that which is being used partly in the boiler for quite for converting the water into steam, then the radiant superheater itself, and to the drum itself. The superheater is being sent from the drum like this, and there are arrows which going on this which is going up and everywhere, and the water coming out of the water or mixture of water, steam jet or water is coming out from the drum from here and goes to the superheater itself. Then the deep from superheater goes to the deep superheater main stop valve where it is completed. We are controlling it, and then going out of the furnace itself. So we are finishing the class here.